Now I will be talking about a net force with forces in only a certain, well, opposite directions. Okay, a Newton is the SI unit of force. It is the amount of force that will give a mass of 1 kilogram and acceleration of 1 meter per second squared. A kilogram on Earth is equivalent to 9.81 newtons. A vector is the force of a particle in a certain direction. For example, if there are two opposite forces with respectively 10,000 newtons, well, one with 10,000 newtons, and the other force with 9,000 newtons, then you would just minus 9,000 from the 10,000, and this would just equal to 1,000 newtons in this direction. But what if there are more than one forces acting in the opposite angles of each other? Well, for example, if there is a box again, and there are two forces going to the right, and this force has 10 newtons and this one has 15 newtons, and this force has 5 newtons. Well, then you just add it together, and that's 25 newtons this direction, 5 newtons this direction. So then it's 25 minus 5, well, equals 20. So then it's 20 newtons of force in this direction. And that's the very basics of a net force. Now we're going to calculate the net force of 3 different vectors. Well, this is also called the net force eventually when you calculate it, but a different method is required. To calculate the net force of different angles, first you split all forces into horizontal and vertical components. After this, you add the horizontal components and the vertical components separately. So here you have the horizontal component, which is 2 to the right and 1 to the left, cancels out, so there's 1 to the right. And the vertical components in this, there's 1 upwards, 2 downwards. The one vertical force upwards canceled out one of the downwards forces, and that makes 1 force downwards. So then you could just put it here into the triangle. By combining these two, you could use Pythagoras. And from here, you could just simply fill it in to find the force of all these vectors combined. So here you would just plug it in. 1 squared plus 1 squared equals c squared. 1 squared, just 1. And 2 equals c squared, and the square root of 2. Well, you could actually just replace this with newtons in a certain direction. So this is 1.41. Let's just round it off with that. So then this force is 1.41. This force is 1.41 newtons in this direction. But further on finding direction of the force, I will talk about in a bit. Now that we have found the magnitude of the combination of forces, we will look at the direction using the angle, which is measured from the positive horizontal line. And to find the angle, we use the inverse tangent. And now we're specifically trying to find this angle, alpha. But say if you were to try and find this angle, you would switch these two around, which is important to remember, that the adjacent side and the opposite side will always change depending on the way that you look at it. So the inverse tangent is the opposite side divided by the adjacent side. So that is basic, so that's just 1 divided by 1 in this case. But then also on your calculator, you could shift tangent, well, it has to be in a specific mode, and then bracket 1 divide, well, depends what the numbers are. 1 divided by 1, well, not the numbers, but the adjacent side and the opposite side. And that will give you the angle and the direction, and in this case 45 degrees. But we said that we would only look at the positive horizontal line. So then we would go around. So it's 360 degrees minus 45, so it's 315 degrees is the angle of, well, the angle and the direction of this force. So now we have the complete net force of the combination of forces. Now we have, this is the square root of 2. That's the amount of newtons. At an angle of 315 degrees. Now that the net force is discovered, it can simply be plugged into the equation. Acceleration equals the net force over mass. This is very important because in Newton's third law, as stated before, mass needs to be taken into consideration. And the degrees is not the angle is not necessary to have, but you can use it if you want to know in which direction the force is going.